to do at least one item live coding, which is going to be trying to get the you got yeah. We're going to try to get show in the free transaction palette how to do a test involving fees, which I don't know exactly how to do myself. I mean, I do kind of know how to do it, but I have to figure it out. Um, and then I also want to notice this. If you're trying, so there was a question here about Genesis build, and I can definitely see how there's some confusion because 7 months ago, or like a little bit ago, they deprecated this old Genesis build syntax for a new one. This is PR 14306. And I believe the template that you guys are, the template that you all are using is in the old one. So if you use the latest frame, latest substrate, it will have a different syntax than what you need to use in your template. And I'm sorry, that sucks. So what I'm going to do during the lunch break, I'm going to add Genesis to one of the palettes. That will work, and then you all can copy it if you need it. Remember that if you're running the problem with Genesis, for now what you can do is just create a helper function, a setup function, which does all the storage you want, and then just call it at the beginning of your palette, or beginning of your test, right? But it is cool that you want to use Genesis, so I'll also include it. But I guess it's like, one of the pains of Substrate is that you're using a template, it's one age, this project has deprecated, so I apologize. Okay, so we're going to do one quick example before lunch. Not quick, it's probably going to be a little bit intense. We're going to try to, in the feeless transaction palette, see if the fee isn't taken. Now, let me actually suggest what I would do in terms of how I would test this. I think that for a unit test, it's not so important to check actual fees are taken. It's important to check that dispatch result is pays equals no. And then you assume, you're assuming that with the unit test, that some other palette, if pays equals no comes in, it does its correct job, right? There's a unit test and there's an integration test. So integration test actually checks end to end. Does my runtime do everything it wants? But a unit test, it doesn't make sense to unit test the logic of fees, which goes elsewhere, right? Does that make sense? So I think really what I want to do inside of your palette is just test that the free transaction is happening, right? So I think inside of my stuff, I already have this free transaction, which returns pays no, right? So let's see if I can write a quick test to see that pays no is coming through, and that would be good enough for me to confirm that this is working. So there's a test, fn, pays test, I don't know. Okay, and then we're going to just call this function. How did this function, what was the function I wrote? I wrote if you put success equals true, it will happen. If not, it will fail. Okay, that's easy enough. That's an easy API. Thanks, Shawn. Okay, so asserting OK here is not good enough, right? That's the whole point. Asserting OK will work, but it doesn't tell me any information about the free transaction. Oh, that's not the format. This is palette, free transaction. What I actually want to do is I actually want to take the result and then actually look into it, right? So instead of doing just assert OK, let's do let result, let res equal free transaction. And let's maybe just look at what that result looks like. So let's just do print line into res. And then let's do assert false to make the text show. And I should have all the data I need in here. Ooh. I should have all the data I need in here. Oh, I'm missing a whole true. True. Okay, so inside of this OK is a post-dispatch info with actual weight, none, pays fee, pays no. Now this none is coming from the fact that you put default weight, right? So whatever. But this is what you want in fact. So basically, if I can check this pays fee inside this OK is there, that is none, that's good. So I would maybe make the function like, okay, let okay, let does pay equal res, let's see, match. What is the best way to do this? I'll do match statement, I guess. Match res. Okay. Some info. By the way, there must be an API for this. So I'm gonna do it by hand, and then I'm gonna look quickly if there's an API. So if there's an info, then info dot pays fee. Wait, info. Yeah. If there's an info if so match again. Match info pays fee. If pays no, return false. If pays yes, return true. And then if this isn't okay, then we know that they'll pay fees. So we return true, right? So there's a function here which gives me a does pay, true or false, and I can assert does pay. Well, I want to assert not does pay, right? Pays, okay, I need to import pays. Use frame support waits. Deprecated alias, what? Oh, it wants me to change the import. Frame support dispatch pays. Okay. And it works. So, I mean, this is, I think, the most simple way of doing it. Again, and the idea, the context around this is that you're writing unit tests. Your unit tests can only really understand what it can do. So there's an API to control pays. You've sent it pays no. Actually understanding that the fee is taken or not, that's kind of extra, okay? Now, let's quickly check if this thing has its own API. No, that's okay, fine. You can do this, right? This looks fine, it's simple enough. Probably if you go inside of the dispatch pays fee thing, there's probably an API that you can just call a thing on it and it will just get it to you automatically, right? But this is easy enough, okay? What I do want to show you, maybe not, I'm not going to program it, but we do have integration tests inside of Substrate which do check feeds. So if you go into Substrate, bin, node, the main node, runtime, source, lib, I guess. Somewhere here's the tests. There's more unit tests somewhere. Testing, source, that sounds good. Lib, Genesis, client, B. Okay, let me check in here. Template, runtime, source, lib. Test. God, I don't know what's going on. Yes. Oh God. Way too intense.
Can you maybe show how to test hooks? Yeah. Oh, okay, yeah. Okay, thank you.
my multiplier will be against the weight of a balance transfer, right? And the balance transfer is kind of a very, it is a really nice like base unit in my whole blockchain. My blockchain has many different functions, many different weights, many different complexities. But in terms of all blockchain, the balance transfer is kind of like the, de facto baseline thing, right? So I think if we do a weighting off the balance transfer, that would be good. So let's say in my lib, I have here a new type, which is like base weight unit, right? Which is a get of weight, right? See this note? Base weight unit missing notation. Sure. Okay. Talking into the mic here. Okay, so let's go into the, however you like it, yeah. Let's go into the mock and let's just add our base weight thing. So type base weight unit is equal to I have to implement it. So I have to do a struct base weight unit impl get weight for base weight unit fn get return weight, and it's going to return right now weight default weight 1. I don't know if that's allowed. Let's try that. Base weight unit. Okay, but I'm gonna replace that with something better soon. Okay, I need weight in the get in scope. Wait, it doesn't have 1, it has 0 though. Cannot leak a private type. Thank you. Pub. Alright, here's the base part. So now basically, if I can get the weight of a balance transfer in this function, I'm solid, right? So let's go ahead and do that. So I think what I want to do is I want to create a call, let transfer call equal, and I can do this in my runtime, because my runtime has balances palette. I can't do this inside of the palette that I'm building because it doesn't have balances palette in it, right? This is the runtime. I have access to everything. So transfer call is equal to palette balances, : call with the runtime test transfer with some arbitrary user. Oh, okay, that's interesting. I need to make an account. I need to have an account. Okay, well, that's fine. I mean, inside the test environment, everything's okay. So the transfer parameters, let's go back to here. Let's find fn transfer inside of balances. Frame balances source lib fn transfer. I guess I have to do transfer. Let's do transfer allow death. So it'll be origin destination value. So transfer allow death is the call I want. And so there's no origin. Destination will be 0, right? That's an account. I'll make it a little more explicit here. So this is let Alice equals 0. Again, it doesn't matter who I send it to because the weight will be the same, right? We know this. And then the value will be balance. Let value equals 100. That also doesn't matter what the value is here, because I can do this. Dest. No, that's fine. Value and values value. Okay. So let's first check that this compiles. I need to return a weight. So this call should be a real call. Okay, it looks like it's good. Then I want to turn it into a runtime call. So let runtime call equal, and with the type runtime call equals palette balances. Transfer call dot into. Transfer call dot into. And then I can do let weight equal transfer call dot get dispatch info dot weight. This is what I showed in the examples inside of the code. So I gave you these hints already for this function. Not on calls because I need to import the function. So I'll do use frame support dispatch, get, okay. Transfer call moves. What, do I use it twice? Transfer call. Oh, I guess I don't need this. I don't need this runtime call. I just need to directly call the wait on the transfer call. Okay, and it works. So I'm just going to turn wait here. And then I think it will be interesting to see wait. Use struct literal syntax. Oh, yeah, it's a variable. Wait. All right, then it will be interesting just quickly to see what that wait is, right? So inside of my tests, I can make a new test. Test fn wait unit. I don't think it needs to be inside of a externalities environment, but I can do test as create config : base wait unit : get, right? That's the let base wait unit equals this. And I do print line BWU. I do assert false, false. Let's just see what that wait unit is. I need to call get. I need to have get. By the way, don't drop imports in the middle of your code. You know, clean up your code nice. Okay, so you can see here now I have a number that's sensible. Okay, this, like you might be, you know, in your test you might be like, okay, that's a big number, but this is the weight of a balance transfer, and now you can say, okay, well, you know, when you lock up 1,000 tokens, it's equivalent to 1,000 transfers, and 1,000 transfers could mean 1 democracy call, could be 2 treasury calls, could be whatever, right? It's like some kind of mapping unit, but it gives you like a baseline. This is how much a transfer costs. This is a pretty good starting point. I would multiply scalar onto this, right? So if I wanted to have, for example, 3 times the BTU, let 3, oh, I can't do, so BWU, there's a 3 BWU, it should be as easy as doing BWU dot scalar mul, I think something like that, of 3. What do you mean? I need to put a reference on it, is what you're saying?
It's a structure, so you must like take something from the weight, right?
No. The weight is an object that has AP, like, so yeah, so it's not right to just pull out ref time. That what you did there is not right, actually. That weight is an object. It has 2 components. There's a function called, there should be a function that does scalar multiplication. So let's just look real quick into the docs. Where's the docs? I don't have the docs open. Parity tech. Polkadot. Struct weight inside of frame weight. Okay, frame system weights, weight info, weight, here we go. There we go. SP weight. So the SP weight. In here there should be scalar. Yeah, saturating mul by a scalar. So saturating weight, scalar multiplication, computes each field times a scalar. So just saturating mul or something like that, right? That would make sense. So here, saturating mul of 3. Let's try that. It wants U64. Okay, that's fine. Because all the types inside of weight is U64, it makes sense. Okay, so here, now I have weight 1 and then 3 times the weight, and it triples both the components. So this is very much the right kind of idea. Like I lock up 1,000 tokens, I get 1,000 times the base weight units. That's a good vibe.
I did not do this. I just let the pseudo user, which could be governance or whatever, set
Sure.
the scaling multiplication basically
Sure.
from a
That's fine.
balance. Because my thought was.
Well, wait, no, wait, sorry, but actually you did. Sorry. So remember, my palette, I just put in here some input from the outside world weight. So if you're saying that you just okay, go ahead. Tell me what you did.
What I did was a converter from balance to weight.
Okay.
Which basically it doesn't scale the balance; it just converts it to a weight.
Sure. So you're just
And
moving
then
the
it
logic.
multiplies.
Sure. Yeah, that makes sense. So that's basically what here. Just convert balance to weight, which I did here, right?
Yeah.
And then in this,
storage.
yeah.
Multiplication factor, let's say.
Exactly.
One for ref time and one for proof size.
So here, this is the convert function. So I can just move it in here, right? I could just take this exact same logic here, right? And I could do, and this is balance saturating, right? So then I could do this function. This, where's the multiplication? Balance to weight. Wait, am I so crazy? Where did the multiplication go? Oh, it's in my other code. I put it in the extrinsic. Let's just do it here. Okay, let's just do it inside of that function. So here, this. So this is the weight. So I can say final weight is the weight of transfer call saturating mole times the balance saturating, right? And this is final weight. Alice not found in scope. Okay, that's fine. I just put Alice in value. So this is good code. This is like this. So the code was still working, but sorry, this test. Obviously, I meant to make it fail, but this is decent code, right? Like this is code where you let the user fully decide, but again, within your implementation, it kind of makes sense for it to be based off of some extrinsic call. You know what I'm saying?
Yeah, basically did like a 1-to-1, and then multiply with the weights of storage, basically. So one token would be one ref time, one proof size, and then on storage I have two constants that the governance
Right.
set and multiply it.
So implementation detail doesn't really matter. But I'll tell you that this makes more sense from a blockchain perspective because you have no idea what one ref time, what one base unit means. That's a very arbitrary, you're deciding, right? What's actually good in terms of thinking about designing a system like this is anchoring your scalar to some real world extrinsic, right? Like, look at this. Look at the size of ref time. Look at the size of proof size. One is bytes, one is seconds, right? So when you give one of each for one balance, it doesn't make any sense. You're giving someone at some point, for them to be useful, they need to have a trillion second, but then they also get 10 gigabytes, right? Okay, well, okay, then I don't care what your implementation is, right? It just, if it makes sense, it makes sense. This makes sense to me. Okay. Uncomment to see text. Okay, any other questions? No, okay, so I'm going to work on the Genesis build, and then I'll push that to my code, okay?